So on Friday, we finished right here where we were solving log equations and we were having to condense to be able to solve so that we had just one log on either side, then get the arguments out. But remember, we had to take into account the domain because the domain for log functions are not all real numbers, right? So let's look at example 5. It says, let f of x equal this, let g of x equal this, and we're going to find all values of x where the graphs of f and g intersect. Okay, so before we do anything, since we're going to have to solve something, let's go ahead and look at our domain so that we don't forget to do it or that we do it at the wrong step here. So I'm going to take this little function right here, this x plus 15. I know that that has to be greater than 0. So x has to be greater than negative 15, right? Then I have this one where x has to be greater than 0. And that's it. And then this where x plus 3 has to be greater than 0. So x has to be greater than negative 3. So of those three, which one is my actual domain? The second one, x is greater than 0. So this is the domain that I'm actually using here. Okay. All right. So over here then, if I want to know all the x's where the graphs of f and g intersect, how am I going to set something up? What do I do? How do you know where things intersect? What has to be true when they intersect? Draw on your paper. Draw a random whatever and another random whatever like it's on a graph. And what do they share when they intersect? A common point. So how am I going to know where that common point is? Algebraically. Well, I could. So if I had two lines, I could put them in point slope form. That is probably one of the ways that you solve that. So if you did that, so let's say that these were two lines, and I put them both in point slope form, then what would I do with them? Like, how do I set up something to solve it? Set them equal to each other. Exactly. And so I think that's where your mind was going with that point slope form, because you probably set them equal to y and then set them equal to each other when they were lines. Okay? But they don't have to be lines. Also, they could share more than one common point. That's definitely a possibility. If you think about, like, if I had a parabola and a line, they could share 2 points, right? Or if I had something else, they could share multiple points. But if you want to know where they intersect, then you would set the two equal to each other. So that's what we are going to do here. It is not a parabola and a line. They are both logs, but, all right. So that means that I'm going to have the natural log of x plus 15 minus the natural log of x equals the natural log of x plus 3. Okay. And I've already taken care of the domain over there. So remember, you have to do it at the first step. You can't do it like after you've done a few other steps. I mean, you can do it later. You just have to make sure you do it with the equation that you started with. All right, so on the left-hand side, I'm going to condense. So this is going to become the natural log of what? Okay, x plus 15 divided by x equals the natural log of x plus 3. Okay. So now I have a single log on both sides. So I can take the arguments out and let x plus 15 over x equal x plus 3. The fact that it's a natural log and not another log makes absolutely no difference, does not make it any more difficult. All right. So then to solve this, I'm going to multiply both sides by x, right? So I'm going to get x plus 15 equals x times x plus 3. So x plus 15 is x squared plus 3x. What kind of equation is this? Quadratic, so what should I do next? Set it equal to 0. And would you move everything to the left or to the right? I would move everything to the right so I can keep my x squared positive. Absolutely. So 0 equals x squared plus 2x minus 15. Then what do I need to do with that? quit because I don't know what to do? We'll just skip it and move on to the next one. What do I do here? Factor it. Okay, so I'm going to factor it. So 0 equals x and x. And what are my two numbers? -3 and +5, or +5 and -3, however you want to do it. It's totally fine. So that means x is equal to -5 and 3. Are both of those my answers? No, because x has to be greater than 0, so it is not that one, and my only answer is x equals 3. Okay. Any questions? Alrighty, then you work on number 6. Make sure this one's right first. Is that what you got? All right, so make sure so I will finish working it out in just a second, but I'm giving you a chance to work it out. That's your actual answer. I'm giving you that because I'm not going to just do it for those of you that still can't factor. I'm going to give you a second to get yourself through it. But if you factored it, you got 2 answers, and that was your final answer, then good job. Give everybody else a chance to finish working it. Yes. Yes. And so that's just were you not here? You weren't here Friday. So what that is, while everybody else is finishing, it's the domain. So for a log, so let's just think about a parent function for a log. Looks like this, right? And it's not all real numbers, right? My x's they can only be greater than 0. But then when other things happen, we get shifted or whatever. Yeah. So, but no matter what happens, whatever's inside, that I can't take the log of 0 and I can't take the log of a negative number. So that has to be greater than 0. That's why I set each one of those greater than 0. And then, so all 3 of these things have to be true at the same time. And since that's the biggest number, that one just kind of takes over all of them. Does that make sense? But yes, it is in the video. Okay. So let me finish factoring that for those of you that need to copy it down. So 2x squared, let's see, minus 7x plus 4x minus 14 equals 0. So then I'd factor out an x. That will leave me with 2x minus 7 plus 2 times 2x minus 7. So that gives me x plus 2 and 2x minus 7 equals 0. So x equals negative 2 and 7 halves. But because my domain has to be greater than 3 halves, it cannot be negative. And 7 halves is greater than 3 halves. That one's a pretty easy one to compare, right? And then I have this right here. Okay, we're good with that? What questions you got? Extra stuff there. We all good? If you could factor that just fine, you have mastered Algebra 2. Those of you that still can't factor and don't know what to do, you still need to go back and master Algebra 2. I cannot reteach you how to factor every single time we have to factor. All right. Any questions besides how to factor? Okay, good deal. All right. So now let's go and we're going to do the same type of thing with exponentials. All right. Do we have to check the domain for the exponentials? What do you think? What's the domain for an exponential? All real numbers, so we don't have to check the domain. We're fine, okay? So if we have the same base, just one exponential expression on each side with the same base, then it's the same type of thing with the log. We can take the arguments out, and right here, well, if I had a pen, right here, we can just say that 5x minus 1 equals 2x plus 7. And then let's pause right there because I forgot to say something up here. I always do that. I want to make sure that you understand when you're going through the process here, you cannot jump from here to here. Even though you know you're about to combine them and you're going to be able to take them out, the rules, your work has to be logical. It has to follow math rules. And the math rules are that we take this, we condense it, and then after we condense it, now that we have a single log on both sides, now we can take the arguments out and get here. Does that make sense? And then when you solve, if you're skipping steps or whatever, that's fine. But that progression kind of has to be there to show that you're following the log rules or whatever. We good with that? Okay. So I've got 5x minus 1 equals 2x plus 7. I can just solve that. So I'm going to get 3x equals 8. So x equals 8/3. Okay. On B, my exponentials do not have the same base, but can I change that 8 into a base of 2 to some power? Yes. So 8 is 2 to the what power? Third. So 2 to the third that's my 8, and then I still have it to the 3x minus 2 power. That's equal to 2 to the x plus 5 power, right? So now I have common bases. This is my power to a power rule. So when I take them out, this gives me 3 times 3x minus 2 equals x plus 5. So that's 9x minus 6 equals x plus 5. So 8x equals 11. X equals 11 over 8. Everybody okay with those? Yes. All right, then you try C. What would you make your common base? 3. What questions you got? Anything? Okay, what would you choose for your base on D? Well, I couldn't have 4 as my base, but I could use 2. Could I make my base 1/2? I could, but I think most of you would probably choose 2 instead. Like 1/2 or 2 is fine, but I think that most people are going to go down the 2 road, which is completely fine. So let's do that. So 1/2 becomes 2 to what power? -1. Good. And then that is to the 5x plus 7 power. And then 4 becomes 2 to the 2nd power to the x power. And then you finish that up. Any questions at all? Okie dokie. Then we are good.